Hello, we're Team 23. We're doing our project on a lightweight electric folding longboard. So you can see on the right, this is the GrabCAD model and the prototype version. And we see some trademark features as being the folding joint, which just improves your storability, the carrying handle, which really dignifies your carrying experience, and the electric propulsion unit, which lets you go really fast and a little bit further than you would walking. Some potential markets and consumer viability. We're looking at urban commuters and college students as our primary market for this because they're just in the perfect environment to use an electric longboard. And then tech enthusiasts, if we sort of capture the imagination like the hoverboard did back in 2015, we could get a lot of interest. The market's growing. The alternative transit market is growing pretty quickly, so that means that it's a good environment for an electric longboard company. We're planning to make and sell about 50,000 of these because the base materials are pretty expensive. So we're going to do the minimum run we can do for this class.
This is the CAD model of the unfolded and folded state of our electric folding skateboard. The model was retrieved from a GrabCAD model. Here is the exploded view and part list. There are 30 parts, and the parts indicated with a star are the ones that we plan to manufacture. There are 14 in total.
Next is product analysis. The FAST diagram describes the functions the board must perform. Main functions are support skater and rotate wheels. The function component mapping matrix maps the components of the board to the leaves of the FAST diagram that describes the basic functions they must perform. Most components perform multiple functions, with many sharing control direction function. This is likely due to the electric motor drive that connects multiple components to the spinning wheels.
The first assembly sequence works by starting from the middle and working outwards. So we'll start with the handle and foldable connectors and then move into the forward deck with the front baseplate axle assembly. Next, you turn to the rear of the board and assemble the backwards deck and the rear baseplate axle assembly. And then last, you put on the motor and the power supply parts to finish the product. The second assembly approaches the process slightly differently by working from the back, which is heavier, to the front. So this time the heaviest drivetrain parts are assembled closer to the beginning, and then it continues to move longitudinally along the product until reaching the front. Here we are using this table to decide which assembly would be easiest from a manual assembly perspective. Sequence 1 wins, with the largest differences being the ease of transferring and handling, where the heaviest components are put on last compared to the other option. And then the parallel assembly works better when working from the middle outwards since it's more symmetrical.
This is the bill of materials for the folding skateboard. Items highlighted in yellow are the items we plan to make. There are 14 of those items. All other items are totaled to 30. The total unit cost is $236.98. Tooling cost is $8.14. Assembly cost is 80 cents, and processing cost is $28.16. The assembly process is mainly manual, and majority of the components are cast machined, while the deck is CNC'd.
Based on primary product functions and costs from the BOM, the following quad chart was developed. Most of the functions of this board are of high importance. The component exceptions would be the handle and handle rods, and the manufacturing cost was broken down into more or less than $5 per part. So the high category are those parts that were more than $5 and are of interest for DfM. Moving on to product family design. So functional differentiation is shown on the left. The main differentiating factor is the additional technology that secondary group tech enthusiasts would want to see. That would be represented through functions such as improved battery cooling, vibration reduction, or direction control, for instance. This carried into the modules, which would be the battery compartment, and electric motor, as these are the key components which tech enthusiasts may want to have modified or enhanced.
Here you can see the two variants for the battery compartment. Given that our main customer group are tech-savvy individuals, the battery compartment was now designed to include two 50mm speakers, and the housing is now made out of acrylic plastic to improve the overall aesthetics. All of the battery and music control information will be managed on an application that is made specifically for the consumer. Here you can see that the initial design was only a one-wheel drive skateboard. The drive unit was redesigned with a new shaft and pulley system, which will now work simultaneously to propel both wheels. This is the product family assembly diagram for the skateboard. You can see that there are many components to this product. Because of the fact that many components cannot be assembled before others, there has been difficulty optimizing the assembly of the product. This is something that we will have to consider moving forward with the redesign.